Hello and welcome back to my bench. Today we want to talk a little bit about these little relays which are sitting in the low pass filter which are behind the power amplifier of our ham radios. And you might know that these low pass filters are necessary to suppress the harmonics which are caused by the power amplifier and non-linearities and so on. So, well, today it is not to talk really about the low-pass filter and how it works, because you can see here more low-pass filters side by side, and they are for the different ham radio bands. So on what band you are working, the dedicated filter gets switched in and will suppress your harmonics. But well, so we do not want to talk about the low pass filter itself. We just want to talk a little bit about the relays, because as I said before, it depends on which band you are working. The dedicated filter get switched in, and the filters get switched in by these relays here. And you have always one relay which is in the direction of the power amplifier, and the second one which is connected as you like to your antenna. And you know, these relays can really give you a hard time, because sometimes you cannot really distinguish, is it now a relay which is not working or not working properly, or is something wrong with the low pass filter itself. So, you know, sometimes there is no other way to get them out and check the little relays out of the board, the PCB, and you know, this is how this little relays look like. So they are, well, this are relays with translucent cover. The more modern one are, yeah, you can't look inside, so it might be even more difficult to know what's really going on, because on these older versions you can see if the mechanic works. So that might tell you a bit, but it does not tell you really if this relay is working properly, because you should not forget, in or through this relay we are sending RF. So that means we normally start in our shortwave radios in the 160 meter band, and our shortwave radios very often goes up until the 50 megahertz, and therefore you are really applying RF to these relays, and the behavior of such relays is different to if you only put DC to it, or you put RF frequencies up to 50 megahertz. So therefore you must find a procedure how to check them out. And well, to say it very clear, this video is inspired by Paul, Mr. Carlson's lab, and he already showed a very nice testing procedure of this little relays. And I put the link down below to Paul, and Paul has a very nice method to check this out. Well, I just want to show you different methods, and as well the method already presented by Mr. Carlson's lab. But I think it is really necessary to point it out because, as I already said, this can really bring you a hard time. So I have already done a troubleshooting on low-pass filter in an earlier video, and there you can see how the filter behaves when or if a relay is not really working properly. So I will link it below as well, so you can see this very early video where I did the troubleshooting. But today it will not a troubleshooting on this board, so we will just look into how we can check these relays when you have taken them off. Well, relay is really no rocket science, so it is simply a coil, and we are passing DC through, and then, you know, the coil itself behaves like a magnet. And well, inside, so this is a bigger relay to see it a bit better. So here you have the magnet, and if you apply DC to it, then, you know, it behaves like a magnet, and then it will switch the contacts inside. So that is really simple, and there is nothing special. And okay, this is then the relay size, which is built into our into our ham radios. And well, what we have is if we have the relay engaged by putting 12 volt to it, then you have a contact, and it is like this. So it is switching between two contacts. So that is what you can see here. And this is the mechanical connection to it, so that then this contact can switch. So that is, you know, basically nothing special. But well, when you look inside, I hope it is you are able to see it, because you can see a little bit the contacts in here. And well, after a period of time, this contacts really becomes critical, and you may have attenuation by bad contacts, and that will have really funny behavior of your low pass filter. So therefore you really need to take care on what is happening to your contacts. So okay, so how can we test it? So I have here a simple power supply, and it is adjusted to a 12 volt because our radios are working normally with 12, or if they are installed into a car, with 13.8 volt, so something between 12 and, let me say, 14 volt. And to test, I have simply a power supply which is adjusted to 12 volt, and we want to check how the relay is working and if we are able to check it. So therefore I have taken again this bigger relay, and we are going to apply 12 volt, or this is a little bit more, so this is a 24 volt relay, but that doesn't matter. It is just to understand how it works. And yeah, I will apply the power to the coil, and then you can see the contacts switching, and that is what I want to show you. So have a look down here to the contacts, and yeah, you can hopefully see that there is the switching between the two contacts. And we have exactly the same with our mini relays here out of our ham radio. And when we connect this little relay to, let me crank the power down, so now it is on 12 volt, and now I will apply the voltage as well, and you also can see, so look here onto this white plastic, and you clearly can see that the relay is switching. Do you? So I mean, this is a first indication, and it will tell us that you know, this coil is working, and mechanically it is switching. Sometimes you find this kind of relays in our ham radios where the coil is interrupted, and that is the reason why on one band the radio won't work. So therefore this could be the first fault indication if you have problems on one band. So there can simply the coil interrupted, and therefore this is really a first indication on the function of this little relay. But of course this will not tell us if the contacts are good or bad. Well, and of course you can check the coil inside the relay simply with an ohmmeter, and I have already connected the probes to the coil, and here is our ohmmeter, and what you can read is that the coil has a resistance of 362 ohm. So that is also telling us that the coil is okay, but we have already seen it because you see the mechanic working. So this is already the indication that the coil is working. But anyway, this is a way to check if the coil is good or bad. And well, sometimes you really can measure in this case 360 ohm, but your relay doesn't really move. So that is what we have seen before. Yeah, let me disconnect it. Yeah, we have seen this little white plastic moving, so that is what we have seen before. And sometimes also we can measure our 360 ohm. We do not see the relay working, so that is then an indication for that there is some mechanical trouble inside. And that is something you have to have in mind as well when you are troubleshooting a low-pass filter, or especially this little relays. Well, and then easily to check the contacts inside is when you connect an ohmmeter to the contacts, and you apply your 12 volt to the coil, and then you should read a very low resistance. And yeah, here it is. So the ohmmeter is connected to the relay, and you can find here, so that is 80 milliohm. Okay, so that is really a very low resistor, and we can say, okay, so no problem whatsoever. So that is what we want to see. When the relay is switched, we want to see such a low resistor. And if this is a relay which is somewhere inside a DC circuit, somewhere in a DC circuit, so that the contacts are only used to switch DC, then you would say no problem, you can use it. With such a low resistor, you definitely can be sure that your relay is working. But, well, what happens if a relay like this is connected to RF? If it is really part of a low-pass filter in an RF application like our ham radios are. So in this case, the behavior could be different, and therefore we are going to check the behavior as well under real RF conditions. Okay, so to test it under real RF conditions, I want to sweep the relay from 500 kilohertz up to 50 megahertz, and that is really the entire bandwidth where our ham radios are working. For the moment in time, I have simply connected the output of the sweep generator, out of the tracking generator, back into the input of the analyzer. So this is simply a connection, so there is no attenuation in between, nothing. So this is just the test application, and it will show you. So let me go a little closer, and it will show you. Let me check if I can do it a bit better from the light we are using. Maybe now it is a bit better. So what I wanna show you is that we are feeding minus 10 dBm right out of the tracking generator, and what we want to see is this line. So we start, I don't know if you can read it, let me do it this way. So we start, as I already said, with 500 kilohertz, and we go up to 50 megahertz. So this is the entire bandwidth where our ham radios are basically working. And what we want is that our relays in the low pass filter are able to handle this entire bandwidth. And you know, therefore I'm feeding in minus 10 dBm, and as you can see, the tracking generator level is minus 10 dBm, and what we want to see is a line like this over the entire bandwidth, and we do not want to see attenuation which goes lower, or some funny curves within this bandwidth. So what we want to see is what we see right now, because that is the behavior what we would expect from the relay contacts itself. And sometimes the relays introducing you funny behavior over the respective bandwidth, and well, we can evaluate our contacts by simply viewing the behavior, and that is what we want to do in the next step. And I hope you have got the idea how this circuit will work, and how we make sure that the minus 10 dBm which are fed in are lead back into the spectrum analyzer input. Well, and this is a little test setup. So the relay is simply connected here into this little tin, and so that makes it easier to connect it here in between. So that is the whole idea, to get it here into the line of our tracking gen. So now I need only to connect the 12 volt to the coil, and then this test can be done. So yeah, that will be next then. Okay, so now we have here our test setup, and what we can see is that we put the little relay into this tin and connected it to our tracking generator. And here we have our power supply to switch the 12 volt to the relay that it switches. And well, then we have dialed in a frequency sweep from 500 kilohertz up to 50 megahertz, and that is the entire shortwave band in which we may work. And well, so let's see how the behavior of such a little relay is when it gets swept through the entire bandwidth of shortwave and yeah, of course 50 megahertz band as well. So okay, I just get a little closer so that we can better see the screen. And yeah, one information additional to that, the upper line here is 0 and one below is minus 10 dB, and the level which is feeded in is minus 10 dBm. So it should be, if everything is okay, so we should see a line going through as we have seen it before. And now I switch the 12 volt DC to the relay coil, and let's see what happens. And yeah, that is really interesting, because as we have seen it before, we should have the relay or the sweep sitting along this minus 10 dB line, and it should go straight on. But what we see is and look the behavior. So that is the behavior of a faulty relay, and that is really difficult to find with if you check it with an ohmmeter, right? So but now it is still 10 dB under the level it should be, and that is not very nice. Oh, I think that is a little mistake in my take. Okay, so sorry, we still had minus, we still had the ref level at 10, so this line here is the right one. So that is where we find our minus 10 dBm. So now it is as it should be. So we are feeding in minus 10 dBm, and we are sweeping from 500 to 50, but this is definitely what we do not want to see. So this is the behavior of a faulty relay, and you may imagine what happens if this relay is sitting in your filter, especially in your low pass filter. So that is what is happening. Now I'm taking off our 12 volt DC from the relay coil, and so this drop is of course normal. Now I'm just want to switch it sometimes, and you see we still have, now it's getting good. So remember, should be here along. Now it is still minus 5 dB too low, so the attenuation right now is 5 dB, and that is not nice. So let me put here our marker onto it, and what the marker is telling us. So the signal is at minus 13 point whatever dBm, and as I said, we are feeding in minus 10, so it is still too low, and you see it is varying, right? And if I take away the voltage, and now have a look, so you see this minus 27 dB, and if I go more down in frequency, so we are at so let me go for instance to our 40 meter band. So now we have minus 32 dB attenuation, and now it comes back. And if I go and just knock a little bit onto the relay, you see this relay is definitely dead, and this will cause trouble in the low pass filter or wherever it sits in our RF application. So this is not what you want to see, and still minus 17 dBm, so we are 7 dB under the limit or under the level we are feeding in, and that I hope shows very clearly that this is the behavior of a faulty relay. Because when I'm switching here, so if this is sitting in your low pass filter, for instance, and you switch the relay as often you are pressing your, or you're keying your PTT, and as often you are keying your PTT, the relay has to switch on and off. And you can see sometimes it is okay, like now, well, it is minus 12, and that means 2 dB. Sometimes, yeah, now it is 14. And remember, 3 dB is half the power. So that is very important to know. 3 dB means half the power. So if you have a transceiver putting out 100 watt and you have in your low pass filter attenuation of only 3 dB, that means you have lost half of your power. So you must be very careful with these dB values, right? So, and again, as often you are switching or you're keying your PTT, have a look now. So you have really a huge attenuation. Now it's getting a bit better. And yeah, I think you clearly see the idea, and you clearly see that we have a faulty relay right here, which you can't see with an ohmmeter, because with an ohmmeter you put only DC onto the contacts, here down in the relay, and you're measuring the resistor. So that is definitely something different to when you put RF frequencies here onto the relay contact. So, well, you know, I hope you have understand the idea, and you have understand that you really need to use different methods of checking a relay. So it looks very easy, you know, you think it is nothing special, but you know, a relay is really tricky, and that is what this experiment should show and demonstrate. And that here is now the excellent test setup what Paul from Mr. Carlson's lab already showed in his video. And yeah, as I already said, the link is down below. And yeah, we have here our little relay, and we just put a lot of not a lot of, we put a frequency of it is now about 20 Hertz, and that are a lot of switches which normally this relay have not to do. So normally, you know, it is switching on and switching off, and this puts some stress onto it. And well, I just did it here on the breadboard, and it is a bit more simple as Paul it already showed. I just connected here my signal generator with a square wave to the circuit, and this is only to amplify the square wave where we let the switch, where we let the relay switch. This is only the output control. So there you can see the 20 Hertz on the control screen, but that is only to control at least the circuit. But this is what we really want to see with Paul's circuit. So this is yeah, we call it a component tester, and it is also called Octopus. So that is now connected to our relay, which is sitting down there and clicking with 20 Hertz. And well, here is the output, and this relay, what we can see here, is a good one. So we do not have any bounces, and we see that it must be a low resistance, because otherwise this would be sit in another way here on the screen. But I think I do not need to explain it once again. I guess you have the idea, and to understand the complete circuit and to understand how it works, please just have a look on Paul's YouTube channel, linked down below. And Paul really explained it very, very nice, and you understand how this works. And yeah, therefore you have now seen the different methods how to test it. So this is very good to test our RF relays, and the tracking generator method, which you have seen before, is also very good. And to test it only with an ohm meter is really, if your relay is sitting in a DC circuit, so that means if only DC is passing through. But if you have RF application like we have it here in our low pass filter, then you need to use either this method as very nicely described by Paul, or you use the tracking generator method, and then you can be sure that you have a clear indication or a clear proof if your relay is faulty or if it still works. And then you can go ahead with your troubleshooting if it is not your relay. Okay, so I guess that it is for today. Yeah, once again, here is the little relay working very hard. for the moment in time, and I guess you really hear the clicking. And well, so that's it for today. If this all makes a little bit sense to you, just give me a big thumb up for this video. Don't forget to watch the tutorial on Paul's YouTube channel. And well, thank you very much, and catch you next time. Bye bye.